Lesson 9.3, tangent and secant properties. Now in the diagram we have here to the right, line M is called a tangent. Now this tangent is different than the trigonometric ratio tangent. All right, two different tangents. All right, they have different meanings here. When a line just touches one point to a circle, that's known as a tangent line, right? Because it intersects the circle at one point. Now we have a property involving tangent lines, tangent and radius theorem. If a line is tangent to a circle, then it is perpendicular to its radius. All right, here's the radius, perpendicular. All right, here's some notation to go along with that. Line M is tangent to, here's a symbol for a circle, circle A, and a circle is named by the center point. All right, so M is perpendicular to AB, and this arrow going both ways means vice versa. It means that if this line is perpendicular to the radius, then we know that it is tangent. For example 1, determine whether AB is tangent to circle C. All right, how are we going to determine if it's tangent? Well, here I have this triangle, and if I could prove that it's a right triangle, then I know that the lines are perpendicular, and AB is a tangent line then. All right, so how do you prove it's a right triangle? Let's apply the Pythagorean theorem. 9 plus 16 equals 25. 25 equals 25. That checks off to be true. It is a right triangle, so AB is tangent to the circle. All right, part B. Same deal as before. Apply the Pythagorean theorem. 4 squared plus 5 squared equals, now what am I going to do here? All right, well, what is this length? This is the radius of the circle, so that's 4. So the hypotenuse in this case is 6. So that's 6 squared. Watch out for that. So I have 16 plus 25 equals 36. So I have 41 equals 36. All right, and that's not true. So the answer is no. All right, AB is not tangent to the circle. Find the value of the variable. Okay, what am I going to do here? They tell me that I have a right angle here. This is R. This is R as well. It's the radius. So this whole length here is R plus 8. Make sure you do not put 8R. You're not multiplying the values. You have to add them up. Be careful with that. So I have R squared plus 12 squared is equal to R plus 8 squared. Next big basic algebra mistake that students make is they do a little distributing thing with the square and they write R squared plus 8 squared. Do not do that. That would be incorrect. You have to expand the power and FOIL. And if you FOIL, you get a different result than if you had made that basic algebra error prior. So I have this when I apply the FOIL method. All right, let's simplify that. Alrighty, then I subtract R squared, cancels out. I get 144 is equal to 16R plus 64. Subtract 64, I get 80 is equal to 16R. Divide by 16, and R is equal to 5. Done. On to the next ideas. Tangent segments theorem. All right, tangent segments from a common external point are congruent. All right, here's the external point, and both of these segments are tangent to the circle. They touch one point, so that means that they are congruent. All right, so example 2 says, find the value of the variable. B and D are points of tangency. All right, so these two segments are tangent to the circle, so they are congruent. And all I have to do to solve for x is set those two expressions equal to each other. All right, right, subtract 3x here. So if 10 is equal to 4x minus 6, add 6. And I have 16 is equal to 4x. Divide by 4. X is equal to 4. Done. Part B. Okay. These two segments are tangent to the circle, so they're congruent. So I have 3x squared plus 5 is equal to 17. All right, then here I'm going to subtract 5. 3x squared equals 12. Then I'll divide by 3. X squared equals 4. Then I'll take the square root of both sides. Don't forget to include positive, negative, and x is equal to positive negative 2. All right, now you cannot have a negative length for a segment, but in this case, x does not represent the length of the segment. If you plug it back in here, you'll be squaring the negative, and it still works. When you plug it in, you'll get a positive length. So the answer in this case is both positive 2 and negative 2. Watch out for that. All right, in the diagram, line K is called a secant because it intersects circle P at 2 points. All right, here's the 2 points where the line K intersects the circle P. All right, now we have a couple properties here involving secant lines and intersecting lines. So here we have the intersecting chords theorem. Here we have two chords that intersect, and if that happens, then you know EA times EB, right, both parts of the chord, the product, is equal to the product of both parts to the other chord. For the next one, we have secant segment lengths theorem. All right, so we have two secant lines here, pass through 2 points. Right? Okay, so I have EA times EB, notice the pattern, is equal to EC times ED. All right, that's a property for secant segments. Tangent and secant segment lengths theorem. All right, this one's interesting. Here I have a tangent line. So I have EA, and I don't have two parts in this case, so you have to multiply it by itself. EA times EA, which is EA squared, is equal to EC times ED. It's very similar to the previous property. All right, but just remember, since you don't have two parts, you got to multiply it by itself. All right, let's do example 3. Find the value of x. All right, so I have two chords here. So I find the product of these parts, 9x, is equal to 3 times 6. So 9x equals 18. Divide by 9. X is equal to 2. Done. For part B, I have 8 times 9 is equal to x times 2x. So I have 72 is equal to 2x squared. Don't forget the squared part. I have to divide by 2 first before I square root both sides. Take the square root of both sides. And here I have positive negative. X is equal to positive negative 6. Now, do I use the negative in this case? No, because if I plug it in here, I have a negative length, and that's not going to work. So take away the negative case. X is just equal to positive 6. All right, applying the secant and tangent properties. Here I have two secant lines, so it's going to be 5 times 7. Sorry, not times 7. 7 plus 5, which is 12. And that's equal to 6 times 6 plus x. Make sure you don't write 6x. All right, so then I'm going to have to distribute here. 60 is equal to 36 plus 6x subtracts 36. I get 24 is equal to 6x. Divide by 6. X is equal to 4. Done. For the next one, I have 4 times 22. All right, watch out for that. A lot of students will write 18. Notice the pattern for the property. All right, there we go. So same thing as before. Here I have 88 is equal to 36 plus 6x. Subtract 36. And I get 42 is equal to 6x. Divide by 6. X is equal to 7. Done. All right, example 5. I have 4 times 4 is equal to 2 times 2 plus x. Distribute. I have 16 is equal to 4 plus 2x. Subtract 4. I get 12 is equal to 2x. Divide by 2. X is equal to 6. Done. Last one. Here's my tangent. I have x multiplied by itself times x is equal to 9 times, what's this whole thing? 16. So I have x squared is equal to 144. Square root both sides. Don't forget the positive and the negative. X is equal to positive negative 12. Does the negative case work if you plug it in? Nope, you cannot have a negative length. So just working with the positive case. X is equal to 12. That's all there is to it. We're working with tangents, secants, and chords as well. If you have any questions, please make sure to ask. Begin the assignment.